Hey everybody, welcome to Lambda School's mini boot camp. I'm glad you all could be with us today. My name is Dan Frainer. I am a full-time instructor here at Lambda School, and we're really excited to be able to offer this 3-week mini boot camp to everyone for free. It's a really fantastic opportunity, and I'm really glad you could join us, and we're going to kind of work through kind of all the building blocks of basic web development and really get you a taste of what it's like to get started in it. And it's a great introduction. And we will, it's a great introduction. You'll be able to build stuff at the end of the 3-week course here. And we, if you so choose and want to join us for our full-time program, it's a great introduction, and it'll be, a great way to see what we do here at Lambda School and what you could potentially do as a full-time web developer or software developer in the real world. So yeah, it's really awesome that we were able to provide this free boot camp, mini boot camp here. Over the next 3 weeks, we're going to be going over 12 lessons. The first lesson is tonight, and we're going to start with Git and Github. I'm going to get you an introduction to kind of workflow developers work with using Git and GitHub. Then we're going to move into HTML and CSS, get you a good basis for HTML and CSS, and then we're going to move into some JavaScript. JavaScript is the language that the web runs on, essentially. And we're going to have 8 lessons on JavaScript. It's pretty, it's going to start by the very most basic parts of JavaScript, and we're going to work all the way to some advanced topics like recursion and closure and callbacks. And then we're going to wrap it all up at the very end with a core or a lesson on DOM manipulation, and that is going to kind of bring the HTML, CSS, and JavaScript all together, and we're going to have them working harmoniously together, and we'll have you build a little mini web app for the final project. This is, essentially we're building a front-end web app over the next 3 weeks, and yeah, it's fantastic. We're going to go through a lot of really cool stuff. So that being said, we do have support throughout the time here. We have Lambda School TAs that are offering their help in the questions channel, the help channel, and then each lesson is going to have, we're going to have our very own channel for each lesson, so you can direct questions about that specific lesson to that channel. And if you're in Slack, which I highly recommend, well, you should be if you're here, you just hit that channels button on the left side, and then you can kind of scroll through and see all the channels that are available. For each lesson, we will have an assignment. And, they start off tonight as pretty simple. It's essentially just creating a GitHub account, and we'll go through all of that right now. And then, when we get to the JavaScript assignments, those are, they can start to get a little more difficult as we build up our skills. And so definitely reach out, any questions you have. Any questions that you pose in the questions channel will be directed back to me, so I can read those live on air, and we can get to a couple of those as we go. But other than that, please reach out in the help channels and in each lesson's specific channel as well. So that being said, just want to talk a little bit about Lambda School and what we do here, and kind of what this course will set you up if you do choose to apply to Lambda School. Lambda School is a 6-month computer science immersive, and we really reach some really cool stuff throughout the way. The first portion of this course is a kind of a web-based development course where we go through everything from HTML and CSS, React, Redux. We touch on a lot of front-end development stuff. And then we go into a back-end portion as well where we get into Node.js. We talk about MongoDB, MySQL, some relational database stuff. And then that's the first half. And the second half of the course is computer science related. So we touch on Python, we touch on C, and get into some really deep computer science concepts in that course. And so it's really a great course. It's 6 months long, full time. So that's Monday through Friday from 8 a.m. to 5 p.m. Pacific. And it's all remote. And so that's a really great thing. You can do it from anywhere. Lambda School has a unique situation where we don't charge anything up front for our school. And only when you graduate and get a job do we expect to be paid for anything that we've provided. And that is actually would be 17% of your pay if you get a job in the software development world, making more than $50,000 a year. You would be expected to pay 17% of your income for 2 years. And that caps out at $30,000. So if you go through the entire course, and once you get a job is when you start paying. So it's really an awesome opportunity that we're given to allow anyone of any means to attend for free while they're in the course. So we do have a course starting the first Monday of each month. The next course starts on March. Let me find it. March 5th will be the next course that starts. If you do want to apply for the March 5th course, please reach out to Karen Zachary and let her know that, and we can expedite the interview process for you. And so as we go through this course, this is the required prerequisite for joining Lambda School. And anyone that goes through the mini boot camp here and finishes their course does get expedited interview times and a leg up on everyone else that's applying. So work through this mini boot camp, finish the course, and reach out to Karen, and we can get your application expedited. If you're just here to check out what web development is about and software development in general, and just want to learn a thing or two, you absolutely can. That's what we're here for as well. So with that, we will get started. Let me answer a couple questions. We do cover C in the second half of the course, so we do touch on it. And so that is, so we just got a question. I believe you need to have a bank account in the United States. I'm not sure. Let me get back on the U.S. citizens question. But we try to make this as inclusive as possible. But there are some legal barriers to it. So I will get back to you on that as far as if you are required to be a U.S. citizen or not. And yeah, so let's start sharing my screen, and we'll get started with today's lesson, which is our lesson on Git and GitHub. And so today we're going to talk about what version control is and Git. We're going to talk about our terminal, basic terminal commands, Bash Terminal. We're going to talk about forking and cloning an existing github.com repo, and we'll explain what github.com is as well. Then we're going to go through some basic Git commands and a developer workflow and how we not only write our code, but how we save it to memory and how we make it available for others to look at and to use. And then the final thing we'll go over today is submitting a pull request, which is we'll have everyone submit a pull request, and that'll be your how you turn in your assignments. So we do have a couple of prerequisites for the course. It would be advisable if you are on a Mac, Windows, or a Linux machine. It is possible to get a Chromebook to working through the mini boot camp, but it's pretty difficult once you get past the mini boot camp level to continue working through it. So I would highly recommend a Windows machine hopefully with Windows 10 or Windows 7 on it, a Mac, or a Linux machine. And Linux, since there's so many different flavors of Linux, there's a step-by-step instruction that we'll share with you that allows you to work from your Linux machine. So the prerequisites we have are a github.com account, and I'm going to go through that with you first to set that up and what it is. If you're on a Windows computer, and I will share the link to this master repo here, and you'll have all access to all these links. If you're on a Windows computer, we'll need you to either, the easiest way to do it is to install the Git Bash Terminal, and you'll see that you just download it, and then you'll have access to Git Bash. Windows doesn't come preloaded with a Bash terminal. Well, there's a such thing as WSL, which is a Linux machine running inside of Windows. For more advanced users, you might find that that's the best case scenario for you. But for most of our students, Git Bash works just fine. And so recommend, well, you'll need to install either Git Bash, or if you're an advanced user and you'd like to install WSL, you can do that. If you're on a Mac, Git is pre-installed. You can access it from your terminal by pressing the command button and space, and then just typing in terminal. And you'll get this little terminal window that pops up there, and that's what we'll be using. Linux, you may need to install Git by accessing your terminal, and we'll have instructions online for doing that, to getting it installed on Linux. One thing to note is if you're on a Mac, it may request that you download the Xcode developer tools, and there should be some basic instructions in there. The first time you use Git, it takes about 1 minute, and it downloads it. Everything's free, and then it allows you to use Git. And all of the stuff we're talking about today is free and accessible for free online. And so, yeah, so you'll need to have Git installed, and possibly you'll need to install a separate terminal if you're on Windows. So what is Git? You've heard me say this about 20 times already today. So Git is version control. And version control is a concept in software engineering that applies to the management of our source code. So, I always like the analogy that, if you're working on code, you're usually not working on it by yourself. If you're on a team, professionally. And so you have this, this file or massive folders full of files that everyone's kind of working on at the same time. Without version control, essentially only one person could work on a file at one time. So it would be like a library book. You had to go and check it out. Nobody else could look at it or touch it in that time until you put it back on the shelf. And that allowed it so that changes could be made to the file synchronously. Version control is this concept where if you're on a team, a group of developers, everyone can work on the same exact file at the same exact time without really much fear of stepping on each other's feet. And it allows us to do so by creating something called branches. There are a lot of systems for applying version control practices to source code. We're going to be focused on the most popular at the moment, and that's Git. There's also TFS, there's SVN, and there's a couple of other popular version control solutions as well. But essentially, the main concept is that we want to be able to work on the same exact files together as a team. So Git was created in 2005 by a guy named Linus Torvalds, and Linus Torvalds is probably best known for writing the Linux kernel operating system. He wrote it in 2005, and it allows, like I said before, a team to work concurrently on a single project, or we call them repositories, and you'll hear them called repos quite often. Just know that that's what it is. It's a single project is a repository, all while staying current and up to date. So Git does this through a process called branching. So each member of the team, each feature that member of the team implemented, you would break off a branch of that master tree trunk, right? And so each person had a branch that they could work on themselves, And then when it was time to put that code back into the master source code, Git has this amazing way of evaluating where the changes were made and kind of slicing it up and inserting the changes back into the master branch. And so if all goes well, Git is gonna just kind of fuse all the changes back together into the master branch, and everyone's code that the things that they've added will be available in the master without stepping on each other's toes. Git also acts as a sort of a time machine. So every change you make along the way and every change your team member makes along the way, you will be able to go back and look at, all the way back through the history of the beginning of the repository. So you're going to be able to see all the changes that everyone made. This is really helpful, especially if you're working on a large team. Say someone 2 months ago wrote some code that broke something a little bit in the code, and you're now finding out 2 months later, whoa, that one button that we hardly check is not working right now. So you can go back through the history of the code, find out where that change was made, and remove it or fix it. And so it's really an awesome tool that allows us to kind of travel all the way through the entire history of the repository through that code project and see who made the change, where it was made, when it was made, and be able to remove it or fix it as well. And so that's Git. Git is software that lives locally on your computer, and we'll go into it in just a moment on how to get to that. And so, Git is something we're going to use on our computers. GitHub.com is essentially a network to store your repositories. I say it's a repository of repositories. It's not the only one on the internet. There's a couple others, Bitbucket and GitLab, and GitHub just so happens to be the most popular and the one that employers look at the most, the one where most open source software is hosted. And you can think of GitHub.com as kind of like a Dropbox for software. You can store it there, you can pull it down, you can push it up to change it. It's just where it's stored. So it's like a cloud storage solution for software. One thing to note is Git is not synonymous with GitHub.com. They're two different things. GitHub just so happens to host Git repositories. Like I said before, you can work with Git locally on your computer and then upload it to any of the Git repositories online. Just GitHub just so happens to be one of the more popular. It's a place that you can go and look at other open source software. You can go and find other people's projects. It is a really great community. It allows people to work together, and you have developers from all over the world working on open source free software for use by all other developers. You can read the code, you can see people's projects. It's really a great community that they have there. And it also acts as a portfolio for any code you work on. So anything you work on, you can upload to your own personal GitHub account. And most employers would expect to see a link to some sort of code that you've written. So that's a great thing to put your GitHub link in there, and they can go and look at all the code you've written and see, who you are as a developer. And it also works really well when you want to upload code and ask for help or assistance on something you're working on. You can share your link with someone, and it's just a really great place. If you're planning on being a developer, you should probably have a GitHub account. And so, it's really simple. We're going to all need to do this tonight. Just go to github.com. You'll see that I'm already signed in. We can sign out. And it just has you right here. There you go. I would highly recommend that you pick a username that is professional because most likely you are going to be sharing it with future employers. Use your full name and an email. And hopefully, if you're planning on applying for the full-time program here at Lambda School, use the email that you use to apply with us and the full name that you use to apply with us as well. So I'm just going to move this over. I'll sign in. One thing I do want to point out, it is very helpful if when you go into, you sign up, you create a profile, you'll go to public email and pick the email that you use to sign up with us and make it public. It's going to allow us to find you easier and look at your code, and it's going to allow employers to find you. It's going to allow recruiters to find you. And so, use an email that you would want professional email going to, and you will need to verify it. So that's pretty simple though. Get logged in on GitHub, and then when we can start here. So let's talk about the terminal. Let me open that terminal up. And I'm going to use iTerm right now. So this is what a terminal looks like. I'm going to just preempt this by saying the terminal itself is this really wonderful window into what your computer is actually doing. But it can be really intimidating, especially for new developers. It's text-based. There's no graphical interface to it whatsoever, but it's really powerful. I'll say that everything we tell you in this course is going to be completely safe to use your terminal through. If you do find something online that tells you to copy paste a line of code into your terminal, just make sure you know what it's asking you to do. And it comes from a trusted, reputable source. Because it's something that you copy paste just off some website you found very well could do malicious things to your computer. But that being said, everything we are going to talk about in this course is absolutely fine to do in your terminal. It's very powerful, the terminal is, and it really gives you access to what your computer is actually doing without all the fluff of the graphics on top of it. Okay. And so the terminal takes a bit of getting used to. You have to memorize some commands to give it. You have to kind of work with it a bunch to learn how to do the things you want it to do. It's really powerful. We can traverse our file structure, add files, remove files, update them. There's a lot we can do with the terminal. And you're going to be using it extensively throughout your professional development career. So it's a great time to get accustomed to using it now and just get acquainted with it and learn, kind of start figuring things out. On Windows, this is going to be your Git Bash Terminal. On Mac and Linux, this will be your terminal, is what it's called. Like I said, it might look scary at first, but in time you're going to really enjoy using it. And you're going to use it more than you would any graphical folder structure. So let's go over a couple of commands right now as we get started. The first command is called ls. This gives us the list of all of the folders and files in the current directory we're in. And a directory is just another name for a folder. So you'll see I've got applications, Lambda school folder. You see these are all folders in here. So ls just gives us whatever is in the current folder we're at. The next one is called cd, which is change directory. And remember, a directory is just a folder. And so let's go. You say cd space and the name of the folder you want to go into. A great feature of using your terminal is you can type in a little bit of where you want to go to and hit tab, and it will autofill it for you. Okay, so it doesn't give you a whole lot of feedback here, but if you hit ls again, you'll see that it's gone into the terminal or into that folder. So ls is list, so it's list all the files and folders in the folder I'm currently in. cd is change directory. The next one is mkdir. So let me, so you can cd into a folder, and if you want to back out of it, you just hit CD and 2 dots, and that will bring you 1 level up. Clear that. And so Mkdir is going to be just as it looks. It's going to make a directory. Remember, a directory is just another name for a folder. So I'm going to say Lambda school pre-course. And you'll see now that it's created the folder. There's nothing in that folder yet. All it's done is created the folder. So let's CD into Lambda school pre-course, and we'll see that there's nothing in there. The next terminal command we're going to talk about is called touch. And so touch is going to make a file. Mkdir makes a folder, touch makes a file. And when it makes a file, it's just going to be an empty file. There's not going to be nothing in it. So in this exercise, we're going to make a file. It's called newfile.js. Make an ls and see that new file is now in the folder that we are currently in. The last terminal command we'll go over right now is the rm command, and that's remove. Rm, and we'll do newfile.js. And so, like I said, it's not very friendly. It doesn't give you a lot of feedback. It doesn't tell you newfile.js has been removed. And that's something to think about as well. There is no prompt telling you, are you sure you want to remove this file? And it doesn't move it to the trash can. It doesn't move it to your recycling bin. It deletes it permanently from your computer. So if you use RM, just make sure that what you are deleting is exactly what you want to delete, because there is no going back from it. If you feel like you want to delete it, but you're not sure if you really want to, I would say just go ahead and use your My Computer or your Finder or something like that and delete it from there, because then it'll give you that backup. But if you're sure you want to delete it, you can do RM. Also to note, this is RM only deletes files. It won't delete folders without a couple extra flags, and we're not going to go over them today. It's a little more advanced. So RM, it deletes a file. And we can see it has been deleted. So an exercise that we're going to do, we'll have you do tonight, and all of the instructions are in this GitHub that I'm going to reference you to. You're going to create a new folder called Lambda School. You're going to CD into that folder, and then you are going to create a new file by touch and new file. Okay. All right. So let's go to GitHub itself now. So we're going to talk about what GitHub is, how to traverse it, and we're going to talk about a concept called forking and cloning on Git. All right. So I'm going to paste the link to GitHub in your in the general chat, and that will be where you can find the all of the lessons and all the assignments that we are going over today. So let's go to it right now. Oh, not tree. Tree, yeah, that's fine. Actually, I'm gonna fix that on Slack real quick. So you're going to be at a screen like this. Hopefully you're signed in and you can see your little avatar up there on the right. And you can always see has signed in as your name, as your profile. So what we're going to talk about right now is forking. So to fork a file is essentially creating a copy of the original file and copying it to your account. And so then that lets you work on that file as much as you like. And then when it comes time, we'll show you how to submit a pull request to merge the files back together. But before you do anything, look up what's in the upper right-hand corner, and that's who owns the file that you're on. So right now it's Lambda School. So if you click on fork, I already have a fork, and it'll tell me there you already have a fork of this repository, but you can click on, you'll probably see your photo. Click on that, And then it's going to, we'll just click on that to show you. It's going to look like this. It's going to take a few moments. It's going to copy all of the stuff in your file, and then you'll get to it. And I'll go to my profile, and I'll show you what it looks like on yours. So then you're going to see that you are now on your profile. So the upper left-hand corner is who owns it right now. So it's me. And it'll see the name of the repository, and then it'll tell you underneath where it was forked from. Okay, so make sure that your name is in the upper left-hand corner before you do the next step. And the next step is going to be cloning. So now that we have a copy of this repository on our GitHub profile, now we want to download all of the file itself so that we can work on it on our computer. To do that, you're going to click on this green button, clone or download, and then it'll come with an address right there. Don't download it or open it in desktop. Downloading it, well, cloning it is going to do a couple of extra steps for us for free that downloading we'd have to set up for ourselves. Opening it in desktop is going to open it in a desktop application, and it's going to be graphical. And that is a viable thing to use once you have the concept of Git down. While we're learning Git, we need to always be using the terminal to do this. That's going to give you the best instruction and the best learning atmosphere. And then once you kind of know what everything's going, and then it's personal preference if you want to continue using the terminal or if you want to use a desktop app. I personally use the terminal for everything. I've worked with developers that will only use the desktop graphical app, but they know what's happening, and that's essential to what we're doing. So to do this, you're going to highlight or you can either highlight it and copy it, or you can just click the copy to clipboard icon. Now that we have this copied, we can go back to our terminal and make sure that we are in the proper folder, which says right here, Lambda School Pre-Course, so we're in it, and we can paste, we can write, sorry, not paste yet. We're gonna tell it Git, and we're gonna say clone, and now we paste the I gotta go get it again. We paste the address. If you are on a Windows computer and using Git Bash, in your settings, you're gonna need to go in and enable control keys. I can't show you because I'm on a Mac right now, but it'll be in your settings, and you'll have to go in and enable control keys in order to copy paste. Or you can write it out, but pasting is real easy. So now that you've typed Git, which is the name of the program, so we're using Git, we're telling Git that we're going to want to use the clone, and then we're going to paste the address of where we want to clone from. So then it's going to create a file for us, a folder called Pre-Course, and it's going to download all of the stuff available or in that repository onto our machine, and it's going to set up some other stuff too. So it's going to set up the address that allows us to point back to it, which we'll show you in just a moment why we would need that. So that's something downloading doesn't do, and if you download it, you'll have to set that up yourself. So remember, Git clone, then paste the address. Now we can see that there's a new folder in our file here, or in our folder called Pre-Course. And so we can cd into Pre-Course, and we can ls, and we'll see that we now have all of the lessons available to us. Once you're in this folder here, then that's when we're going to do the touch new file, touch new file.js. All right, and that's going to just create a new file in there for us. Where is it at? There it is, new file. And that's the first thing we do. So now that we've created a new file, essentially we have changed the what's in this folder. And Git and all of the beauty that it does is it looks for every single change that you've made to that file, to that folder structure, and then it's going to want to save it to Git history. And so we're cloned it now. We've added a new file, so we've actually changed something in this file, and this goes for everything. You can go in, open up these folders, write new code inside the files themselves, save it, and then Git's going to know about it automatically. And so the second Git command we're going to learn after clone is something called status. So type Git Status, and it's going to tell you that you have an untracked file. It's going to say new file is something new. It wasn't there before. Do you want to add this to your Git history? And that's the second we're going to use. Git status is going to just tell you what the status of your current Git repo is. There's a lot it can tell you. Right now it's telling us that there's an untracked file. But Git status is something that you should be using a lot. So every single step of the way, you should just do your Git command and then Git status just to see where you are in your Git file. So the third command we're going to learn is going to be add. So add is going to add that whatever we tell it to Git. So we're going to git add, and then we tell it new file.js. And then once again, not much is given back to us on it. But if we git status, we'll see that something has changed. We've added that new file, and now it's asking if we want to commit the file. So committing is what I refer to as saving your changes to the history of the repo. Remember when we talked about Git being a time machine? You have to commit. So essentially, you have to save your changes in commits. And that's where it will take a snapshot of what exactly it looks like. And you'll be able to go back to exactly what that code looked like at that exact moment. So we like to say commit often because it saves your progress within your Git history. To commit, we are going to say git commit. And then after commit, we're going to give it a flag. So we have a hyphen and the M. That says we're going to leave a message. Commits must have messages, and if you don't give it the M, it's going to open up your default text editor, which could be Vim or Nano or something that's not very beginner friendly. But right now, we're just going to type the M so we can type our commit message in line. And what this message is essentially doing is it's a message to future us or other developers on exactly what you've changed. And so you want to be as precise and as verbose in your messages as possible to be able to relay the information of what has changed. Because if you do need to go back, you're most likely going to be searching the messages for what's changed and looking for exactly what you want to change. So in this case, we're going to say added new file.js. That's a fine commit message now. Perhaps if you were working on something much bigger, and you would have a lot of information to add into here. For now, we've added a new file, and we can make our commit message added new file.js. We press enter, and now it's going to give us some feedback. It's going to tell us that we've created a new commit, and this is our commit hash here. You don't have to worry about that just yet. That's a more advanced thing. And then it's going to have the message for the commit. It's going to tell us exactly what we've done. We've changed a file. 0 insertions means that we didn't add any new code to the project. We've changed a file, but no new code, and we haven't removed any code. And then it's going to say we've created new file.js. There we go. It doesn't throw an error. You're good to go. So now that we have added and committed, the third step to our Git workflow here is going to be push. And you commit often, but you don't push very often. So commit adds all of the changes to your Git history. Once you've kind of done something, or you want to usually you'll push once or twice a day, especially if it's the end of the day, you've worked on a bunch of stuff and you want to really save all the stuff you've changed. You push, and what push is essentially doing is uploading all of your changes back to your github.com account, and so then it's reflected in your repo there. So if we say git push, it'll probably ask you for your username. It will 100% ask you for your username, and then it'll ask you for your password. A thing to note is that when it asks you for your password, you'll see a little flashing key, and you'll enter keys on your keyboard, and it won't look like it's doing anything. Just know that it is receiving your password. It does that for security purposes. So you just type your password as you normally would and press enter, and it will work just the same. So just remember that when you see the password, you see the key and it's not moving, it's not doing anything, that's totally normal, and it is entering your password. So that being said, let's go back to my repo. And now we're going to see new file.js is there, and our commit message is there next to it, added new file.js. So we have now added a new file. We've added it to our Git tracking. We've committed it to the history of our Git, and we've pushed the changes up to our repo. So now it is saved locally on our computer, and it is saved on github.com. The final step in saving your changes is going to be merging your branch back with the master branch. And to do that, it's what we call a pull request. And a pull request is something that should be done very infrequently, non-frequently. And it's only when you're completely done with what you're working on, and you can say, okay, here's my code. Can someone take a look at it? And if everything looks good, can you merge it back with the master branch? For our class, we do want you to submit a pull request tonight. And then the beautiful thing about pull requests are you only have to submit the one for us, because every time you push more changes to your GitHub account, it will automatically update your pull request until it's either closed or merged. So to do that, we're going to click on this button right here, new pull request. And then it'll tell us the base fork is where we pulled it, or we cloned it, or forked it from, excuse me, which is going to be Lambda School, and the base branch is master. It'll tell us our name and our branch, and it should be master. Once you see this, it'll tell you all the commits that you've had in that time, and you can click on Create Pull Request. Create Pull Request is going to open up another screen and allow you to give a much more detailed what you've changed. And so in a professional setting, you're going to want to really go into what you've changed, what files you've worked on, what's different, just really go deep into what's going on. And this is all of your commits. For us, we've added a new file, right? We didn't do much right now. And so we go there, we make sure all that's lined up, we get that green check, and we get create pull request. Once we have created our pull request, that is where our job stops. In a professional world, your manager or the senior developer or your scrum master or someone that is higher than you is going to review all of the pull requests, and you'll eventually be the one reviewing pull requests. And it'll come back and forth, and they'll say, hey, can you change a couple of things? And you'll go back and change them, and then everything will be good, and they'll be able to merge it. You won't be able to merge this. I can, because I have administrative access to the school here. One last thing is you're going to see this some checks haven't completed yet. ultimately, and we'll talk about this tomorrow, we have tests that run on all of your assignments. If this turns green, that means all of your tests have passed, and it shouldn't turn green for another 3 weeks, because you hopefully won't have worked on all of the work until we've gone through the lessons. And you'll see all checks have failed because I didn't complete the tests. But essentially, that is your pull request. So just to go over it again, you want to fork the repo you're working on. Make sure you fork a repo. If you clone directly from Lambda School, you are not going to be able to work on the folder. You'll be able to work on it, but you won't be able to push your changes up, and you'll have to start over. So make sure that you fork the repo, first of all, to make a copy to your account. Then you clone it. So you download it essentially from GitHub to your local computer. You work on all the files that you need to. You git add, and you git add in your terminal. And you add the files you want. You git commit, and that saves all of your changes to Git history, git commit. And then you git push. And pushing is going to upload your changes to your personal GitHub account, and it's going to make those reflected on GitHub. Then once you're ready, you would submit a pull request, and the pull request notifies the owner of the original master branch to look at your code and to either merge it or reject it. So that's our Git workflow. So fork, clone, work on it, add, commit, push, pull request. And that's where we go. And that's about what we have for today. So for your assignment today would be to go sign up for a github.com account, which is absolutely free. Either download Git Bash or get Git set up in your terminal on Mac or Linux. And then to fork and clone the Lambda School pre-course repo. So fork it to your own and then clone it from there. Go through there, play around with the CDs and the LSs and the Git statuses and all of that. You can just play around with it and see kind of how it works. You're going to add that new file. So you're going to use touch to add the new file. And all the instructions are in this repo, by the way. Once you've added the new file, you'll add it, commit it, push it, and then submit a pull request. And that's what we've got for you today. I do have a couple of minutes before we have to take off for this evening. Like I said, if you have any questions regarding any of this, we have our TAs that are hanging out in the Lesson 1 channel for the Git stuff. You can ask questions right now in the questions channel, and I'll be able to see them. And then you can also utilize the help channel as well. Where we have not only a bunch of TAs, but also a bunch of students and former students who are really knowledgeable as well and will help you out. But for right now, just go ahead and ask any questions you have to the questions channel. We have one question is, can I write mobile apps or games once finished with the course? We do offer a React Native module in the course, and React Native is this really awesome tool to be able to write JavaScript, and then that transpiles to Objective-C for, no, not Objective-C, Java for Android, and Objective-C/Swift for iOS. So you will be able to develop a mobile app once done with the complete course. Games is definitely a route that you could go down. We don't specifically offer game development lessons, but you can absolutely use all of the knowledge you gained to go down the game development route. But it's just not a specificity that we focus on. We kind of more teach this computer science that would lead to game development. Also, as far as games go, I believe Unity has a JavaScript way to develop through JavaScript. But you'll get the knowledge to go off on your own and create what you want out of it. That being said, too, you are tasked with creating a personal project, and if game development is something you're focused on and you want to spend your time on that personal project, you are more than welcome, if not absolutely encouraged to do so. But mobile apps, yes. Games, it's up to you. How deep do we go on C? So we use C more as a way to teach further computer science concepts. So we touch on the syntax of C, we write some C, we're not creating C developers here. But you will have exposure to it, you will have used it. We just use it to get to very low level computer science concepts, which is C is fantastic for. Go wait. Get some more questions coming in. So forking, let's go back through it. So I have a question of what's the difference between fork, clone, and branch? So forking is going to be you go to the original where the original repository lives, right? So this is what we would call the master branch here. So we go to the original repository, which I posted a link in the general section. And then in the upper right-hand corner, you'll see fork. And what fork does is it creates a copy of this master branch, and it breaks off a branch for you. So now you're going to have your own personal branch, and you'll have it on your account. Once you've forked, then you'll need to go in to your branch on your account and clone. And what clone does is that it will download that repository, and it not only downloads it, so don't click on download or open in desktop. Remember, you want to use Git Clone and the address itself. And what that does is it will download all of the files to your computer, and it will set up things like Git remote. So Git remote, I believe V. So now it's set up these remotes for me, and you don't have to worry about any of this. I just want to show you what it does automatically for you, whereas download doesn't do that stuff. So it doesn't have push and pull and stuff like that. You have to set those up yourself. So make sure that you go and copy the address, and then you git clone, and then, okay, well, I don't know what's going on there, but git clone, and then put the address in. Okay. So that's the difference between a fork, a clone, and then a branch is your branch, your master branch. So you're going to have a branch off of the Lambda school master, which is the head branch, the master branch, and it's going to create your own branch for you. So remember to fork, always fork first. If you don't fork and you clone directly from the Lambda school branch, you are not going to be able to push your changes up. So make sure that you fork it first and then clone it from your own site. All right, do we have any more questions? Let's see, if I complete the pre-course work a second time, am I able to make a second fork for it? You can't. So if you want to do it a second time, you'll need to either delete your old fork, and I believe that's the only way you can refork it. You can create a new branch for yours that's a little bit more advanced, but since you've gone through it once, if you want to research it and creating a new branch on your local computer, you can do that. So commit is going, so the question was, what's the difference between commit and push? Commit is going to save your changes locally to your Git history. And you need to do that before you push, because when you push, you're going to upload all of those changes to to the github.com cloud, right? So pushing is uploading all of your changes to github.com. Committing is saving all of your changes locally. And so that's on your computer. And that kind of goes into the next question here is, what do you mean by local machine? Local machine is just your computer. It's the computer that you're currently physically working on. That's what I mean when I say local machine. And so it's just your computer that you're working on versus the github.com repository cloud storage area up there. So you'll need to commit your changes before you push. And when you push, it uploads your changes from your local computer, from the computer you're working on, to the cloud, to github.com. And you'll be able to see the changes only on github.com after you've pushed and after you've committed and then after you've pushed. Okay, guys, that's all the time I have for tonight, but we'll see you back here tomorrow at 5 p.m. Pacific. Any other questions, make sure you throw them in the help channel, the lesson 1 channel, and I'll have our wonderful TAs and students that are sticking around to help. We'll get to you. But have a great night, everybody, and we'll see you tomorrow.